How's it going, everybody? In this video we are going to do some troubleshooting. Now I think, significantly broken our BGP, MPLS, VPN core, and it is our job to fix the following tickets. Now I've taken these tickets from the troubleshooting labs that I've done previous to this, and I've basically just I pretty much just randomly went through and started disabling things and turning things off or tweaking them, and basically this it took me about 20 minutes to go through and actually set the lab up from a working config. But the primary thing that I wanted to do is I wanted to break things in different stages. So as we're going through, things might seem to be working, but they're actually not. So it's going to be your job and my job to go through and figure out what's broke and where they're broke. So I'm going to strongly discourage the use of the show run command. And the reason I say that is because with MPLS it's going to be somewhat difficult to try to figure out what's actually broke if you just do a show run. So by doing a bunch of show commands, working our way up, not knowing where the things are broke, because they're broken in random areas. Now I've broken them in random places at random levels. So some things could be BGP related, some things could be VPN related, some things could be IGP related. I'm not going to give anything away, but the tickets you have in front of you are what are broken. Now, I will tell you what the problem is once they're all done, what I did to break them, but what I haven't done is I haven't saved the configs as the troubleshooting scenario. So this is going to be one of those where if you're not sure how something is really supposed to work, if you break it and you can't figure out how to fix it, then that's going to be a key indication that you need to go back and spend some more time. Now I have this little juicy one down at the bottom, ticket number 5. It says the newly created, or I should type in newly created atom connection between R4 and R14 isn't connecting. It isn't working, so it's 4 points. So I have a total of 3, 6, 9, 12, 16 points to get us to a working connection. Now, the reason why they're all 3-pointers instead of ones and twosies is because of the fact that there are multiple breaks throughout. So there might be one where it gets up right away, there might not be. And it's not completely broken. It's broken in different areas so that there's different levels of troubleshooting that are needed to do this. So I'm trying to simulate what we might actually see in the real lab. So, and as you can see, you don't get a whole lot to go on. It just tells you between what and what's broke. Now the first one is pretty much a give me. So if you're not sure exactly how to troubleshoot these guys, it's one of those things where this is a good place for you to start. So if you don't know how to verify your configuration, this is a great place to start working on your verification skills. So now the other thing that I'll point out is just because I have them labeled this way doesn't mean this is the way that we're going to fix them, because you may get in and it might be, the solutions are interdependent, meaning if you solve a problem with one router, it might be solving 2 or 3 other problems at the same time. So they're not the topology isn't big enough for me to implement 7 or 8 different faults right now. Now, one of the things that I plan on doing here is I plan on, maybe just grab my pencil right here, it's easier for me to see it. One of the things I plan on doing is once we get farther along, I'm planning on leaving MPLS up and operational. So what that means is once we get farther along, once I've done the MPLS thing, so once we're done with this troubleshooting section, we're going to dive in and get DMVPN rolling, go through a bunch of DMVPN scenarios, and then we're going to get into multicast and then quality of service, and then some corner case scenarios of BGP and OSPF. Because I'm pretty confident in EIGRP, pretty confident in RIP. I don't need to spend a bunch of time on that. I will continue to work with them just so that I keep up the aspects of it, but the other, like I've mentioned previously, MPLS, multicast, quality of service, DMVPN. Those are going to be the areas that I'm going to spend the majority of my time on, because that's where I want to be as quick with those technologies as I am with layer 2 switching, OSPF, EIGRP, RIP, static routing, and then we'll start doing IPv6 across the board. So anyway, enough yak for me here, right? So the first things we're going to do is we are going to, why is this not showing? Oh, let me get that out of the way. Yeah, for whatever reason it wasn't showing. There we go. So let me pause the video real quick. Now, if you've noticed, I haven't put any restrictions in here that are really, really constringent. So basically, the way that this is going to work is you and I will be tasked with going through here and finding the fault and fixing it. Nothing more, nothing less. And if you have a problem with finding faults, well, it's not necessarily a bad thing, but it's going to be one of those things where if you don't understand what it is you're trying to accomplish, then that's where the problem is going to come into play. So, understanding how the technology works is going to be a key feature, a key discipline, in my opinion, when it comes to troubleshooting. So, I've actually had some people reach out to me and ask me for some troubleshooting labs. I'm not good at giving labs. I'm good at showing you how to troubleshoot them, but labs, on the other hand, it takes a long time to write them, and I just don't have the time. So, I didn't want to do that. So, let's get started with this guy. I did it again. Alright, so first thing we're going to do is we're going to take a look at ticket 1. It says R11 and R6 aren't forming an LDP adjacency. Okay, well that could be, what are the key features when it comes to getting an LDP adjacency? Let's think about this. And I'm going to walk you through each ticket, my thought process, as we're going through here. So first of all, it's specific though. It tells you LDP adjacency. Now I wrote these tickets, so technically speaking I already know it's broke. So I'm going to, but this is where you should be coming from your troubleshooting scenarios as well. So LDP is a IGP based label distribution protocol, meaning it needs an IGP to be operational, right? So that means that in order for R11 and R6 to have connectivity, that means that R11 and R6 need to have an IGP connection between each other. Now, you can use a static route, but I wouldn't recommend using static routing throughout your entire topology. So, with that, enough being said about that for the time being. But when it comes to that, the first thing you need to make sure you have is a route to the loopback. That's what we're using for sure. We already knew that. That hasn't been brought up. I haven't changed anything on that regard. So, the configuration you guys have seen so far is still in place. I've just broken it in different areas. So I haven't gone in there and done anything really weird. I'm different features when you go through your setups. So since LDP is an IGP based label protocol, that means that we're going to have an IGP route to each other's loopbacks. So that's going to be the first thing we check, is do we have, let me bring over our, maybe do this, let me bring this up to the corner here, and bring this up. So first thing we're going to do is on R11, whoop, I did it again. So on R11, I'm going to do a, let me bring this down just a touch. I'm going to do a show IP route. Alright, so do I have a route to router 6's loopback? And I do. I do have a route to router 6's loopback. Let's ping 10.100.6.6. I can ping it. So that's a great sign. Can I trace route to it? That's going to be the other deciding factor. And I can trace route to it, no problem. So that means IGP is working. So it's not an IGP issue. That's the very first thing I always check. Then, is it an LDP problem? Well, it could be. So what are the first things we need to check with LDP? Well, let's see. Let's do a show MPLS LDP, and then interfaces is a good start, right? Not that interface. Show MPLS interfaces? Yes, interfaces. Alright. Okay. Well, we have LDP enabled on this router. Let's make sure that we have LDP enabled on router 6. And let's do show MPLS interfaces. Okay, we have LDP. LDP is there, so we're good to go on that location. So that's not the problem either. So it's not an MPLS issue at the interface level. So what else could it be? So let's see here. Let's do a show MPLS LDP, and we'll say neighbor. Alright, right now we're peered on 11. So we're peered there. Let's do a show MPLS forwarding table. Okay, so let's see, we have, let me bring this out just a touch. It'll be easier to read that way. Alright, so what we have here is, okay, that's not going to give us what we want. Notice, let's see here, do we have a route? Alright, so let's do a show MPLS interfaces. Is detail in here? There should be a detail. Detail. And let's see here. So let's see here. Well, technically speaking, my break obviously didn't work. So, I'm trying to think what I actually did to this one. I forgot. Let's see here. So let's see here. Let's do a Let's do a show LDP MPLS neighbors LDP neighbors. Okay, I guess we are peered. Alright, so LDP neighbors. Yeah, I guess we are peered. That's kind of a bummer. So let's do a, I'm trying to think what I did. You know what? I bet you any money I didn't clear the neighbors. I bet you that's what the problem is. Because I remember what I did. Yeah, see, I've got it. Yeah, I put a password on it. So how the hell do you find that? So show MPLS LDP neighbor detail. Oh, password. Let's see here. Password not required. Neighbor stale. Let's see if that has neighbor password. Show run pipe include LDP neighbor. Yeah, see, I've got the password in here, and it obviously did not work. Let's do a clear. Let's clear MPLS LDP neighbor. And I guess it's not that peering that I'm worried about. I need to be peering off of this guy. This is what I should have done. So let's actually do that real quick. Let's do config t and type in no, and type in MPLS LDP neighbor 10.1.116.11. Password is going to be Cisco, and then do clear MPLS LDP neighbor star. because that's actually what I did, is I configured a password, but I didn't take it down. So if I was to type in do show MPLS LDP neighbor, oh, now it's complete. Now it's really broke. I actually broke it. So let's see here. And the reason why it's not working now is if we were to type in, yeah. So if we were to go to 11 now and do the same thing, so we're just going to reverse the process, and we're going to go to 11 and go to. See, right now it's telling us bad auth, so that's what I didn't do. So we're going to right click and paste. We're going to pull out this guy and put that .6 in, and that should bring us up momentarily here. And let's see here. Why is it not? Invalid MD run pipe include LDP neighbor. No, and pull this one out. I don't want to pull the config off. There it goes. Alright, so that was the problem. So it's got to be not doing the loopback, you got to do the point-to-point connection. So learn something new today. So when you do that, that's how you would do it. Alright, so the next problem, so we're going to that's cool. Well, at least now we know now we know what's going on. So that's a good first sign. Alright, so now ticket number 2 is the R14 transit path to R14 is broken. Find the fault and resolve. Do not remove any configuration. Okay, so that means you can't take anything away. Doesn't mean you can't add or modify. You just can't remove anything. So you can't do a no something or no something. So that's a good sign for us how that works. Now let's go to R4 and actually see if that's true. So let me do this. So we know for a fact that we don't have that route. So let's go to R14 and see what should R14 be advertising. So show run pipe section BGP, because we know we're advertising this route right here, and we're not loading the 10.14.150 route on R4, right? On R4, and we're not loading the 10.14, so we know we have a problem there. So now what we got to do is, because it says R14 transit path to R14, that means we can go one of two ways. We can either go from R4 to 14, or from R14 to R4. So what we're going to do is we're going to start off with router 6, because he's the next logical step. So we have our LDP adjacency back with R11 from R6, and now we're going to do a show IP route VRF. What is that? Red. Alright, so now the thing is we need to figure out where exactly in the transit path we're losing that route. So is it, or is it blue? Because this is OSPF, so it would definitely be red. So we're in the right place. So we're not getting it there. Let's go take a look at router 8 and see if we're getting the route there. Okay, so show IP route VRF brown. Alright, so we have the route there. So now we're going to take a step back towards R7. So that's the key thing, is to say, okay, where do we know where we're learning the route? And then we can start tracking from there. So we don't have to go to R14 and see, are we advertising the route? Or are we filtering it somewhere? We know we're getting an R14, so we know from R14 to R8 we're operational. Then we're going to take a step back to R7. We're going to do a show IP route. Now, what we're not going to see in here is what? We're not going to see any VPN routes. Now, why aren't we going to see any VPN routes in the routing table? Because this is global routing table for OSPF, right? Well, all we need to do is we need to go in here and say what? Do we have a route? Do we have an MPLS route for that? So we're going to do a show MPLS what? We could do LDP binding. That's a good way. That's a good place to start. All right, so we're going to hit enter. And do we have anything in here for 1014? No, we do not. But we don't want to look at the routing table. We don't want to look at the forwarding table. All right, so do we have anything here for 1014? No, we do not. So 7 is a route in between. So let's take a look at our 6 and see if we are even peering between 6 and 7, because I want to make sure I can get traffic at least as far close to 8 as I can. And let's take a look at that. So let's go take a look at that and see where we're at. So we're going to go back to R6. We're going to do a show MPLS LDP neighbors, and we are paired with just router 11. Okay. So, and we know that because of we just have this guy right here. We're paired with just 11. We know that for a fact, so that's a bad sign. Now, why is that a bad sign? Well, it's because I have a connection between 6 and 7 here and 6 and 10 here. So that means that I have issues with the connection between 10 and 6 and 10 and 6 and 7. So let me see if we are receiving any routes through VPN v4. So show BGP VPN v4 unicast all. So we are receiving routes from router 4, router 7 via, so we're receiving an iBGP route from router 7 via BGP, and receiving another route from router 5, but that's coming in. We're learning, what route is that? 10.4. We're learning the 57 route in from router 7. We're also learning the 10.5, so that's the loopback, and the 57 network. So we're learning those. So, but that's okay. So that means BGP VPN v4 is working. Okay. So, but that LDP is broke. Did you notice that? LDP can be broke, but BGP VPN v4 can be working. And how could that work? Well, the reason that could work is because we can have an OSPF route. So let's do a show IP route for the 157, the 100.7.7, and we have an OSPF route. So we have a route to router 7. So that means that we can also have a show BGP. No, show IP BGP. No, I'm sorry. Well, we already saw it. We know BGP is working because we're receiving routes from router 7. So we're actually jumping a step. We're going from IGP, we're jumping up to BGP, VPN v4. So they don't technically have to. I'm trying to think of the best way to put this. You don't have to have LDP operational to have BGP VPN v4 operational. But in order for BGP to give the route to VPN v4 to translate across to LDP down to the other PEs, you need LDP operational, right? Because that's how you get the label bindings. That's how you get the FEC to kick into place. So, what does that tell you? And again, we already knew the problem, so show MPLS LDP neighbors. The problem is we don't have a connection to router 7. So let's do this. Let's do a show MPLS interfaces. Well, we have a connection to router 6 or 7, and it's operational. So how is that operational? So is it a show run pipe include MPLS? So we know it's at the interface level. So is that interface level show run pipe include section OSPF? Well, we know that we are not using the LDP auto configuration command here. We're to do show run interface gig 1.67. We're using MPLS IP. So we know that's the case. So MPLS is operational in router 6. Then we need to, now we've narrowed it down to we know the issues at router 7, right? So we're going to do a show MPLS LDP neighbor. We're only paired with router 8. So, okay. So now we're not paired with router 10, and we're not paired with router 8. So those could be other issues we might have in place. So now the next thing we need to do is we need to do a show IP route. And we have a connection to router 6, which we already knew about. Let's do show BGP VPN v4 unicast all. We know that we have peerings from router 6. We're getting a bunch of routes in from router 6, so we know it's not a BGP route. We pretty much have narrowed it down to an MPLS issue, though, right? So, where have we? Show MPLS LDP neighbors. We do have an MPLS issue, and the reason we know that is because we only have a peering to router 8. We should have a peering to router 7, or I'm sorry, router 8, router 10, and router 6. So now we got to figure out where our peering issue is. So we're going to do a show run pipe include MPLS. So we know it's at the interface level. Alright, so we're also going to do a let's do show run pipe section OSPF. Let's just make sure that it's not an MPLS LDP config. Alright, so we know we're redistributing BGP. Everything looks good there. So good. That's that. So now we need to do what are a couple ways that we can filter LDP? So we know it's not at the interface level, right? Because we have the MPLS IP command at the interface level. There's a question, how do I know that for sure? Okay, well I can do pipe interface as well. So we know we have that, right? So we have the interface, it says MPLS IP. That's how we would know that. If it was LDP autoconfig, it would be under here. It would be MPLS LDP autoconfig. That much we do know. So now, what are the other ways we can do this? Question, is it an OSPF filter? It wouldn't be an OSPF filter because it would show up here, or it would show up under show IP protocols. And if we were to come under OSPF, this is our OSPF configuration, and if it was here, it would say that there's a filter in here. What about, there's nothing under, this is going to be basically, this is where NHRP would pop up. But OSPF 1, we don't have anything configured here. We have nothing in here that indicates that there's any issues with OSPF. So we know it's not an OSPF issue, and we don't see anything with BGP. So what does that lead you to do? Well, there's only filtering left, right? So what are a couple ways we can do that? Well, remember, if we do a show MPLS LDP neighbor, this right here should be a key indicator of what the problem might be. LDP is just like BGP. It's an application that rides on top of IGP in the internal network. So that means that if we're going through, we need to make sure that the connection between these guys is open. So what's one way we could do that? Let's do a show access list. Haha! We have an access list issue. And notice one of the things that's broke here. 646. What is 646 consistent with? LDP. So I not only created a UDP LDP, a UDP 646, I also did a TCP 646. So it says do not remove any configuration. So that means we can't go in here and remove the access list. We have to go in there and reverse the logic to the access list. So how would you do that? We're going to do IP access list extended 100. We're going to type in permit. We're going to type in no 10. Now, you can remove it to reapply it, but you can type in. See, it tells you sequence number 10 is going to be a permit TCP any. Duplicate sequence. See, you can do that, or you can type in. So let's just make it easier on ourselves. Here, we're just going to do no 10 and no 20. But what we're going to do is we're going to say permit. See, there goes our adjacency. So permit And since we have this right here, we're just going to copy and paste it. And we have our, hey, guess what? OSPF came up. And you might be asking yourself, how did OSPF go down? Well, that's because I didn't have a permit IP any below that to make OSPF operational, as I hadn't cleared the routing table yet. So we're going to do a permit TCP IP any, and we're also going to do a permit UDP any. The ticket says, and we have to maintain it, that we do not remove any configuration, we reverse the logic. So show access list, and then we have a permit TCP any. So pretty much. Now we have a permit statements. Now remember, there's an implicit deny any at the end of that, right? So what's going to happen if I don't do anything to this? We should lose our connectivity with OSPF, which we just did. So, and actually we should lose BGP here in a moment too. And why is that? Well, BGP is a TCP connection. If we're losing OSPF, we're pretty much guaranteed to be losing BGP as well. So I type in IP access list extended 100. Type in I permit IP any, and that should allow us OSPF to go back through. And then a show access list, and there's OSPF is back up. So there we go. We're good to go now. Alright, so that solves that issue. So now, does that solve our problem with R4 receiving routes? Nope. Sure doesn't. So what else could be the problem? Alright, so we've done that. So let's go to 6, and we're going to do a show MPLS LDP neighbors. So we know we have connections to 7 and 11, which is good. Now let's go to the right. Let's do a show MPLS LDP neighbors. So we have a connection with 6 and 8 now. That's a good sign. So we're getting end-to-end connectivity back. So we're going to go in here and we're going to say, let's look at R8, and we're going to do a show IP route. Alright, now we're getting a bunch of routes in, which is a good sign. And so we're going to say, let's do a show MPLS LDP neighbors. So we have a connection with 9. We have a connection with 7. That's good. We don't have a connection with 10 though, but we're not focused on that part right now. We're so focused on the 14 to 4. So okay, we have that. So let's do on R14. Let's see if we have any routes in here. Show IP route. Alright, we don't have any BGP routes, so that's a bad sign. Now why is that bad? Well, because we know the BGP is going to be our routing protocol between that. So that's our issue right now. We don't have any BGP routes. So let's do this. We'll say on let's do a show run section BGP. BGP still operational. Show IP BGP summary. Alright, we still have our peering with router 8, so that's a good sign. So can I ping 148.0.0.8? Cool, I still can connect to router 8. That's a good sign. So now we're going to go back to router 8. So that means we still have a connection there. Let's do a show show IP BGP. Well, we have to do it for the VRF. So we'll have to type in show IP BGP. No, it's going to be show BGP. Show BGP VRF brown. All. Right, so we're not loading anything in. No, wait, hold on. Show IP route VRF brown. Alright, so we are loading the BGP route in from router 8. Or from router 14. So that means our peering between this guy and this guy is good. Now, since we know that, let's do a show BGP VPN v4 unicast all. So we're learning just that route in, but we're not learning anything from anybody else. So we don't have any routes from anybody else. So let's take this command on router 7 and see what's going on here. Oh, we got a bunch in here. but a bunch. Okay, so now this is VPN v4. So that means we have some issues now. Let's see here. Where should we go with this? So we're on. Let's do show run or show. Let's see here. What do we want to type in? Show IP BGP summary. So we have peerings to. Oh, okay. Well, here's one problem. We're idle from 7 to 8. We're also idle from 7 to 10. So that means we have a problem there. Let's do a show IP BGP summary. Alright, so we don't have anything going to 7. So, but should we have something going to 7? We should. We should have a BGP peering to everybody. Because we're not doing any type of route reflection, we're not doing any type of confederation. So we should have a BGP peering to everybody. But we don't. So that tells us one thing right there. So what should we do now? Let's do a show run. Now that we've narrowed down to we know what the problem is, we need to figure out what's missing. So show run pipe section BGP. Well, the problem we have is we got two problems actually. We have a problem that our normal iBGP, we don't have a peering to 7 through either normal BGP, so global routing, or through VPN v4. We should have one to both. So that means we got to go to global config. We got to type in router BGP 65000. There's a question. I'm taking an awful long time troubleshooting these. Should I be going any faster? No, I could go faster, but the point is to zero in on the problem. Without using any show commands, we want to, or without any show run commands, we were looking at the show outputs, the configuration of results. That's what we should be looking at. So we need to type in neighbor 10.100.7.7 peer group and iBGP peers. Right click and paste. That'll get us our BGP peering, our iBGP peering back to router 7. And then we're going to type in address family VPN v4 unicast. And then we're also going to type in this guy right here. We're just going to type in neighbor and we're going to say activate. Now, just by getting this one up, that doesn't necessarily mean we're going to have the other one up. So now that we have that going, that's a good sign. Now that we have that route back up, let's go to router 7 and see if we're learning any BGP routes. So we'll type in show BGP VPN v4 unicast all. Alright, well, let's see here. Doesn't look like I'm learning any routes yet. Okay, so alright, let's go to router 4 and we'll do a show IP route. Alright. So I'm still not learning anything in. Router 6. Let's do a show BGP VPN v4 unicast all. Unicast all. Alright, so we're not learning anything in yet from router 8. So, what's the next step? So we've got BGP, so we have LDP is operational. We know that, right? Which means OSPF is operational, correct? It's a good sign. So, next thing we have to do is we noticed the BGP was broke. So we didn't have BGP routes to 7 and 8. So we got BGP working. We also have VPN v4. So let's go back to 7 and we're going to do a we should be learning something out, but we're not. So what could that be? What could that mean? If routes aren't leaving router 8 to go to 7, what could that be? Well, that could be it's the wrong import-export policy, maybe. Redistribution isn't working. But on our 8, we have a position where we're BGP, so we don't have to do redistribution. So that wouldn't be a problem. So let's take a look at the one thing we can do, but I haven't shown you yet, is a debug. What is the command? Debug debug MPLS, LDP, transport events. I believe this will tell us whether or not we are getting no, this is not it. Debug MPLS LDP maybe it is. Transport. Yeah, see what I'm looking for to see is the route target import export values are right. So let me pull this up real quick. See, this is if you're broke. So let me see here. No, that's not what I'm looking for. Let's do show MPLS forwarding table. And yeah, I don't even have the 1014 route in here. So that means that it's not even coming from router 8. I should at least have that route in here. Because I have it on, I have, yeah, I'm not seeing it. So let's go to router 8. So let me verify something on 7 real quick. With the show run VRF, and I should have my import export so I have my import export. So I have that set up. That's good. And we're going to go and do. Oh, you know that might screw me up here. This extra 65,900. That should be okay. Alright, let's take a look at R8. Alright, so what we're going to do here is we got that situated. So now we need to do show MPLS LDP binding or neighbors. So now we know we have a connection with 9, we have a connection with 7. Let's do a show BGP VPN v4 unicast all. I'm not learning any routes from anybody else. That's a bad sign. So, in order to get routes from one router to the next, what do we got to do? And normal VPN v4 will work, but in order to get routes from global BGP into the VRF, or sorry, from the VRF into VPN v4, what do we got to do? We have to have a route target, right? So show run VRF. You look right up here, we have no route targets. That could be our problem, right? So what I'm going to do is I'm going to go to router 7 and I'm going to copy the import export. Let me go to 6 real quick and do that. Show run VRF. He's got a 2. You know what the problem was I was doing some wackiness earlier. We'll go to router 9 and do a show run VRF. Because what I was attempting to do, okay, that's what I copied this in, so it's actually on 7, it's supposed to be 965,000, 65,900. So let me just grab this guy and pull up grab a new notepad document real quick. Bring this in. This is what it should be. And we go to router 7 and pull this out. There's a question, what's up with the multiple route targets? Basically what I was trying to do is, so this one's good. This is the one that needs to go away. right? Export, yeah. So actually, let me Control Z, type in Control A, no, or no. Alright, so basically what I want to do is I want to copy this into all of the routers. Go to 6, config T, VRF definition, red, and blue. There's a question, why am I doing this? Basically because of the fact that I want to make sure that my route targets are set up correctly. And if I don't set them up correctly, I'll run into problems down the road. And the export of 900 to 65,000, I did that in a previous video when I did Central Services VPNs. So that's where it basically came from. So I'm going to do definition. I'm just going to red, and right click and paste that in. So it's going to get rid of that. It's going to clean it up a little bit. So as long as everybody can talk to everybody else, that's going to be the main important part. So you know what I should do? Just do a route target, 1:1 both. But it doesn't matter. So anyway, I just want to eliminate the possibility of having any issues, just routes going directly to. You know what I'll do? You know what? I'll put a no at the beginning of both of these too. And I'm just going to do a route dash target. Both is going to be 900:65,000, and copy this in to router 6, and we're gonna unable to remove extended community. It might be because of the fact it's already in use. That's fine. I'll just deal with it. 9 config T router or VRF definition brown, and right click and paste that in. Alright, so that's fine. 10 real quick to do that as well. Config T VRF definition green, and do the same thing on 11. Green. Yep, so there we go. So now we're going to be using the same 965,000, so that's fine. Alright, so that's good. So now we have to go to R8, and we have to do that. We have to implement that as our route target. So we're just going to go to global config VRF definition brown, and right click and paste that in. So there we go. So now we should have that. So now we should go to 7 and jump out of here and do a show BGP VPN v4. Alright, so we're learning that, or no, we're not learning that route in yet. So let's see, let's go to 4. Is 4 learning that in yet? Okay, 4 is learning it now. That's a good sign. So that we changing the VRF, getting the VRF operational definitely did work. So we're going to do a trace route to 10.14.150.14. So we can get there. We're MPLS label routed over 7 and 8. So that's a good sign. So that means we've solved this ticket as well. So now we're about 49 minutes, and we're good to go. So what we're going to do is, I'm going to minimize that. So I do apologize about some of these little minor issues that I'm running into, but you know, they're all part of the learning process. So what we're going to do now is we're going to take a look. Oh, that's not what I wanted to do. Let me just scrunch this up just a little bit here for you. And so now we're going to say R13 isn't learning any routes from R10. Alright, so now I'm actually going to jump ahead to router to R5 can't reach the database servers located behind R19. So let's see, did anything that I did so far fix that? So I'm going to do a show IP route, and I believe it did. So we see this router. Notice this though. R5 is learning everything via RIP, not OSPF though. So that could potentially be another problem. So we need to do trace route to, what is that, 10.19? Can we actually get there? No, we can't. Alright, so that means that there's another problem. So I actually might have forgotten a ticket. So, alright, so that's a good sign. So we get to 6. So we get to 6, and we die. So 7, that means we should be going via router 7. Because that's the closer hop. We're going via router 6. So we need to go to 7, and on R5, we're not learning. Everything we're learning is via router, is via what do you call it? OSPF or RIP, not OSPF. So let's do a show IP OSPF neighbor, and we have a pairing with router 7. That's good, and it's full. So let's go to router 7 and do a show IP OSPF neighbor. Alright, so we have a connection with 8, 10, 6, and 5. That's good. So are we learning? Let's do a show BGP VPN v4 unicast all. Oh, there's a key indicator. We have a problem. We're only learning routes from router 5 and ourself. So, what could be the problem? Now, if we go to router 6, we do a show BGP VPN v4 unicast all. Got a whole bunch in here. We go to router 4, we do a show IP route, getting a bunch of routes. So what could that tell you? That we might have a OSPF BGP issue maybe? Let's go to router 7 and we're going to do a show. Let's do a show IP protocols. We don't want to jump in too quick and give anything away yet. But in OSPF it should tell you what you're redistributing. In EIGRP it does. It tells you redistributing. Guess it doesn't. Alright, so let's do a show run pipe section OSPF. Alright, we're redistributing BGP. What about BGP? Are we redistributing OSPF? Redistribute OSPF 2. Okay. So, what could that mean? Let's do a clear BGP VPN v4 unicast star. Let's just clear the table. See if that's the problem. Alright, so we're back up. So show BGP VPN. Alright, so we should be learning some BGP routes in, but we're not. But if we go back to 5, alright, so what could our problem be? So show IP BGP summary. Alright, so our connection to 10 is idle. That's not good. So that means we have a connection issue with 10. But if we do a show BGP VPN v4 unicast all. Alright, so we're getting the routes in, but we're not learning anything from anybody. So let's do a show run pipe section BGP. Is anything jumping out at us? Okay, we have a connection to 6, 8, 9, 10, 11. So that's all good. So it's not a BGP issue. And oh, hold on. We learning? Okay, no, that's not it. Why are we not learning anything from there? What is the deal? I could scroll up to the top and actually look, but I don't want to do that right now. I don't think I did anything on R7 that was major. As far as I know, the only thing I did on here was the, what do you call it? I did the filtering. That's the only thing I did. So, let's move to... Okay, so next thing we're going to do is we're going to see our problems here. So we're going to do a show... Alright, so show IPBGP summary. Alright, so, we obviously have a problem on 10. So, if we're, at this point in time, I'm stuck. I don't really know where to go. Nothing's leading me in any direction with router 7. So, this is where one of the times where I've heard people refer to it as cut bait and move to the next problem. So, let's just cut ourselves loose from this issue, because I don't know exactly why R5 is not able to reach that. But we're actually, let's go back to 5 and see if we can do a trace route to that location again. Okay, he gets to 6, but doesn't know how to get there. So we know that's a problem. So let's go to 10, because we know 10's an let's go to 6 and do a show BGP VPN v4 unicast all. Router 9. So can we do a trace route to 10.100.9.9 and source it off of our loopback 0? Six to 10 and 10 over. Yeah. Hey, guess what though? Notice how that's not being MPLS forwarded though. It's being OSPF routed, not MPLS. So if I was to do the same thing to, say, 8, that should get MPLS forwarded. But it's not. It goes to 10, there's no MPLS. It goes to 7, it gets MPLS. So that should be a key indicator right there that we have a problem. So, but if you were to do this from 5 though, you don't get that. You get to 6, 6 doesn't know how to handle it. So if we go to 6, we run into that problem. So now we know we have a problem on 10. Because 10, it hits 10 and we have no response. So let's go check out 10. So that might cause some of our problem. So, okay, so we know that's no point. That's alright. So first thing I'm going to do is do a show IP route, or show IP, show IP OSPF neighbors. So we know we're good everywhere here. So our full DR, everybody's good there. So we know it's not an OSPF issue at the moment. Let's do a show MPLS LDP neighbor. Oh, nothing. Alright, so let's do a show run pipe include MPLS. Alright, so nothing at the interface level. So do show run pipe section OSPF. Oh, wait a minute. Nothing MPLS there. So let's take this a step farther. Router OSPF1, and we're going to type in MPLS LDP autoconfig just for the kicks. So that's going to do that, and so that should get us back operational there. Or will it? I'm going to give you guys a hint. I know it's not working, and I know what to do to fix it, but I'm not going to say nothing. So let's see here. What else could we do? What other problems could we possibly have here? Nothing's coming up though, so by now you should have something operational. So, let's jump out of here and do a show MPLS LDP interfaces, or I'm sorry, MPLS interfaces. It's okay, LDP is operational, but show MPLS LDP neighbors. Still nothing. Okay, so let's do a debug MPLS LDP transport events. See what we got. Oh, we got a whole lot of stuff in here. So, oh, we have problems. Lots of them. And let me explain how this works. Break this down real quick. So, you all, that's a chatty debug. Alright, so, give that a second to clear. Alright, so go back to the top here where we had our first couple pop-ups. And like I said, it's a chatty debug. Alright, so first of all, we received one from 9, so we know we got 9 operational. And we come down a little farther, but 9 is the only one receiving one, and so is 8. Receiving one from 8 and 10. Or, I'm sorry, from 8 and 9. But, okay, but we have 6. To 6, we have a client requesting close of connection discovery hold time expired for 6. 11. Let's see here. 8 did it as well, so we're having a problem with 8 as well. So, but notice where the IP address is. What address is that? That, ladies and gentlemen, is going to be our loopback address. Show IP interface brief. What is our loopback address? Is this. Show run pipe section OSPF. What do we not have operational? Our loopback. We need a loopback. We need an active /32 loopback in order for LDP to form a neighbor adjacency. Unless we change the interface peering capability for this. And now I have 5 different interfaces to do this on. So you could do this and go to global config and type interface gig 1.109. That is the address, right? 109, yep. And hit enter. And you can type in MPLS LDP discovery transport address, and you can type in interface. We should form an LDP adjacency that way, which is going to take it off of what? Let's also do this on, I'm not sure that's actually going to form on that one. So let's do 110. Oh, alright, so we have our that. But we don't want to do that. And you might ask why. And the reason why that is because of the fact that if the interface itself goes down, that means that the connection from R9 to R10 goes down. If you are peering to loopback and you have an alternate route to that loopback, you're going to use another direction. So we're going to type in no. Type in router OSPF1. I'm going to type in network 10.100.0.0. And I'm going to bring up LDP that way. So we should have a bunch of LDP adjacencies come up here momentarily, and we do. So that fixes a lot of problems right there. So now I'm going to scroll up just a little bit here. I'm going to go to, so 9, 6, 7, and 8 are all up. Let's go to 5. Alright, so let's do a trace route to that row. Oh, hey, what do you know? Fixing one problem, fixed that problem. So getting MPLS operational and advertising the loopback back in fixed it. So that means that R5 can reach the database servers located behind R19, which is good. So we can get to that now, which is a great sign. So now we can say R13 isn't learning any routes from R10. Okay. Now what we need to do is we need to go. Now you might be saying, well, you're not getting your OSPF routes to propagate. That's a bad sign. Well, normally you'd be right, but the one thing you got to remember when it comes to the CCIE lab is if they don't specify it in either the configuration or the troubleshooting section for it to be operational, you should not care. This is not an optimization. This is not an optimal routing lab. It's not a best practices lab. It's a technologies lab. They are testing you on your ability to get things operational. So, didn't want to do that. So at this point in time, I'm not really going to be concerned that R5 and R7 aren't learning the routes via OSPF. As a matter of fact, I don't care because I'm actually going to be blowing that away in the next video. So I'm going to be starting over from scratch and starting up with something new coming up in the next video. So the next thing we're going to take a look at is R13 isn't learning any routes from R10. So let's go to R10 first because we just got that operational. Let's see if there's anything else that fixed. So show BGP VPN v4 unicast all. Alright, so we got a bunch of routes in here, right? That's a good sign. So it means that R13 isn't learning any routes from R10. So and last time we were checking, we were EIGRP. So show IP EIGRP neighbors. Well, we're not going to learn anything because we're not in the VRF. So we have to do a show IP neighbors, or I'm sorry, EIGRP VRF green neighbors. Still nothing. Okay, so let's make sure that we have our interfaces up. Interfaces, yep, good to go there. So I know what the problem is, but I don't want to give it away quite yet, and I want to take this. I want to stretch this out just a little bit. So, what other problems could that be? So let's do a ping. Now, I did this before when I was troubleshooting getting EIGRP operational between 10 and 13. So what we want to do is we want to ping to see if EIGRP is even operational before I go in for any further. So you want to do as much troubleshooting from one device as you can. If you're not sure if another router is going to be your key piece. So we're going to ping VRF green 224.00.10. What's that going to tell us? Alright, so we're getting a reply on this address. So does that mean EIGRP is running? Could be. So, if that means that's going on there, let's go to R13 and see what we have going on here. So, we're going to do a show IP EIGRP neighbors. Nobody. Alright. Let's do interfaces. Nothing. Okay. Let's ping 224.0.0.10. And we know that router 10 and 12 should respond. Okay. Now, just because the router responds doesn't mean it's actually running the process. Right? Am I right or am I wrong on that? Just to show IP protocols real quick. What do you think is going to be the expected output? Nada. Just because the router doesn't respond doesn't mean that the process isn't available. So, if we're to do a show run pipe section EIGRP, get a whole lot of nada. So, what we need to do is we need to go to global config and type in router EIGRP 112, hit enter. We need to type in network of 10.1.132.0, and we also need to type in 103. That gets us our connections there. Now that was a little extreme on my part, but you know, so be it. So R13 isn't learning any routes, so show IP route. Oh, guess what? We're learning routes now. So that's a little extreme, and again, it's one of those things where if you ping it, that is not always a dedicated failure solution. But it was working before. That's why it threw me off. I'm like, wait a minute, it's responding to it. So, but because of the fact that the process is available, it will still respond to it. But that could, that could be also a limitation of CSR. So that's a good sign. So right now we've, as a quick recap, ticket 1, R11 and R16, or R11 and R6, that was supposed to be a password issue. R4 and R14, that was quite a few issues. That was, we had an OSPF issue with, can't remember now what I did. We were filtering R7 with transport address. We had an R8, we had a BGP issue. We weren't comparing with router 7. We also had a VPN v4 issue. And then we also had a route target issue. And then we were finally able to get that operational. And then R13 is now learning routes from R10. R4, we had peering issues with R10. And we got OSPF running again on that guy. Or I'm sorry, advertised the right route and enabled MPLS. And then now in this last ticket, newly created Atom connection between R4 and R14 isn't working. So now we got to go to R4. We need to be able to ping show IP. Or no, we can't do that. It's going to be on the PEs, not the CE. So let's bring this up here a little bit. So on R6, we need to, not what I wanted to do. So on R6, we need to do a show IP route. And do I have a connection to R8? I do. So what we need to do here, this is where it actually gets kind of cool. We have to type in, where is it again? Interface, no, BGP? I'm trying to think here, where's the command go? MPLS? Is it an MPLS connection? No, interface gig 1.67 Xconnect, and it's going to be 10.100.8.8. The virtual circuit ID PC is going to be, you'll say, is going to be 200, and then the encapsulation is going to be MPLS. Incompatible with address, command rejected. Incompatible with IP address command. Interface loopback 0. Okay, you can't do it on a loopback. I don't think you have to do an IP unnumbered. Let's do it on 8 real quick. Interface gig 1.78 and Xconnect 10.100.6.6 200, and then encapsulation is going to be MPLS. And so show Xconnect all. Peer. Well, this last one was more of a bonus if I could have gotten it to work. I thought that'd be kind of cool to work with, but So yeah, that's pretty much the troubleshooting section I wanted to do. This next video we're going to get into is I'm going to start really digging into some of the corner cases of MPLS. So we're going to take a look at doing load balancing with MPLS using BGP with maximum paths and multiple route distinguishers. Route distinguishers. The other thing I'm going to do is I'm going to do, not right now, but later on, I might come back and do overlapping VPNs, where we'll have two customers. So we'll say we'll split this guy down the middle, and we'll make, like that, like customer A on the right, customer B on the left, and we'll have overlapping VPNs. I've done Central Services VPN. R9 was the hub, and we had a bunch of spokes going out, and we're feeding R19 routes, and that was working well. Just trying to think of what other MPLS stuff I can do. Because a lot of this stuff you're just playing with the route targets, with like central services and stuff like that. You're just setting up your route target values differently. But I'm going to be setting up MPLS so that when we go and get things operational from the other thing we have to do too is it's more of a BGP implementation, but we still have to do EIGRP site of origin. We still have to do what do you call it? BGP site of origin. Play with that again, and the main piece of that is if you understand that R11 can advertise a route to R12, and R12 can advertise it to 13, and 13 can advertise that back up to 10. You don't want that to happen because then you can essentially start looping. So on R10 you would put a sitemap in to restrict that through a EIGRP community. So it's actually called a cost community, but it's a site of origin. So you eliminate that from being redistributed back into BGP to get re-advertised to 11 to get re-advertised back to 12. Same feature works with BGP, except for you set the route target or the community value, and then if it receives that route in, it'll deny it. But I'm trying to think of what else I can work with you. I wanted to show you something cool with MPLS. I did cover everything that there's out there to cover troubleshooting wise. I did a combination of LDP, BRFs, route targets. What else did I do? Did a lot. I think that was not bad for an hour and 15 minutes. That wasn't bad at all. Remember, I was trying to get you guys to think as I was going through that. I could have solved it a lot quicker, but then again, I knew what the problems were, but again, it all goes back to what I've said from day one when I started into Cisco. If you understand how the technology works from a start to finish approach, so you know how to get it operational from a very, very basic level, you know the authentication, you know the summarization, you know how to encrypt it if necessary, you know how the stub routing works, you know how the areas work, you know how the internal routing versus external routing works, redistribution. You start understanding all these little pieces to it. If you understand that, and if you're looking at something, and for example, when I was creating the lab, one of the first things that I did was, okay, I want to go from top up. So you know for a fact that there's going to be routing. So I'm just going to draw OSPF and LDP right here. So you knew that was going to be in order to get connections between these guys. You know there's going to be BGP to some level, right? So you're going to have BGP there. You know you're going to have potentially OSPF authentication. You might have OSPF encryption depending on the situation. So that'll come into play as well. Then you're going to have your VRF. Now, I didn't want to do anything crazy in this video with pulling a VRF off of an interface and having to reapply it, but that could have been a problem. So you should know how to do that ahead of time. They may not have, your troubleshooting might be, you can't get a route to connect because the VRF isn't applied yet. So do a quick show run VRF to see if it's even there. And you're assuming that it's there, but just go through your different steps, and then once you have that, once you have BGP set up, you need to have BGP running before you can do multi-protocol BGP. So, and then you have your VPN v4. You have VPN v4. You have your VRF with your RD and your RT. So these are going to be pieces that you need to take into mind. And then once you have that, if it's just BGP everywhere, you don't really have to worry about redistribution. But let's say you're doing IGP as a PE to CE, then you also have your redistribution, right? So you have all these little pieces that come into play, and my goal was to play with each one of those. You know, do we have an issue where we're not redistributing routes incorrectly, or you know, what's the deal? So that's one of the things, and I think that might be the reason why I'm not getting it on 7 here. 7. Let me go big real quick. Show run pipe section OSPF BGP. I think I'm not sure if I actually pulled it off or not. OSPF 1, OSPF 2. I don't think that's the problem. I don't remember, to be honest with you. I set it up a few hours ago, and then I walked away and came back, and I said, okay, let's go. But anyway, that's the main feature. So that's the thing. IGP and LDP getting operational. BGP to set up your iBGP connectivity. So let's say R9 is a route reflector. You could have done this with everybody and had him a route reflector, and everybody be a route reflector client. You can also do this with VPN v4. So you can have your iBGP global routing set up for VPN v4 or for route reflection, and also VPN v4 route reflected, and set that up, and then go from there. Now, I mentioned earlier in the video that with the default route target filter, the default route target filter again is if you have a route route target comes into R11 and you're receiving a route target value for a route for a VRF that does not have that route target configured, then it's going to drop it. That is not the case when you have a route reflector set up. It's going to go ahead and forward it. So if you have the wrong route target set up, you can run into problems there as well, which is one of the problems I ran into. So, like I said, I tried to get as much involved as I could with the troubleshooting. So I could make it more on a much larger scale. I could have gotten it a little more complicated, but I figured that was a good troubleshooting scenario, going through and figuring out what was broke. So, but from here on out, I think you guys are in pretty good shape. We're going to look at doing a lot of other VPN stuff. So we're going to take a look at route reflection and BGP PIC and MPLS multipathing in upcoming videos, and then I'm going to start getting into DMVPN and all that good stuff. I've actually got I don't have it pulled up at the moment. Let me pull up my vSphere client real quick. I actually went ahead and I started getting GNS3 ready on another in a virtual machine, and the premise behind that was because there's certain aspects of CSR that you can't do inside of you can't do in CSR that you can do in GNS3. So I have a GNS3 box. This is a Windows 7 machine that I've got GNS3 running on, and nothing fancy. It's basically what I've done is I created. Let me just close this piece out real quick. Is I've got 20 routers. It's basically going to be set up just like CSRs are. I'm just going to copy and paste the config over to these guys from here, so I have all 20 routers operational. I'm just going to copy and paste the configs, change the interface identifiers over, and then we're going to do some stuff in GNS3 that I have to be able to do in GNS3 that I can't do in CSR, like MPLS or multicast over GRE tunnel, multi-point GRE tunnel. So we'll take a look at those. Just some cool stuff as we're going along here, and because like I said, we're going to spend the majority of our time on MPLS, DMVPN, quality of service, and multicast, and IPv6. because I'm actually going to do an entire OSPF v3 section coming up here sooner than later, and go from there. I'm actually doing that sooner than later because of the fact that this MPLS stuff, I don't want to keep the config operational and start digging into little details. I want to keep reapplying it so that my MPLS and multicast and quality of service stuff and DMVPN becomes as second nature and as easy for me to implement as OSPF and EIGRP and BGP are. So those are doing a lot of IPsec stuff coming up, and doing some troubleshooting with that. So a lot of that stuff is going to be more specific study than it is going to be full scale. So I'm actually patiently waiting on more labs to come out, and while I'm doing that, I'm focusing on my weak areas, which is what I would recommend everybody else do as well. So that's my 2 cents for the hour. I hope this has been informative for you, and I'd like to thank you for viewing.